Hello everyone, welcome back to my channel. I really hope that you are doing well, both mentally and physically, and that you are keeping safe and healthy during these unusual times. So in today's video, I'm going to do a little exercise for the element roof construction or roofs and rainwater goods. And having said that, there are items that are measured under this element, and just to name them, we have brickwork, we have wall plate, we have trusses, roof coverings, eaves and verges, and the last item being rainwater goods. Now in today's video, I am going to only focus on two items, and these are the construction wall plate and truss members. Now under the item trusses, I will only focus on measuring the members, and I'm not going to measure the connections and the bolts, etc, etc. I'll probably do that in another video. So yeah, do enjoy, and please don't forget to like and subscribe and comment, and yeah, all the best. Yeah, so the drawing that I have in front of me is our truss detail, and I would just like for us to just go through the various members very quickly, and also over the information that has been given to us. Now, first and foremost, we'll start with that member there, which is our tie beam. And as you can see there from that connection, that means that our tie beam is made up of two structural timbers that have been joined together to give us an 8.6 meter long timber or tie beam. Same thing. Yeah, the first one we will refer to as S1, the second one we will refer to as S2. Okay, S1 starts there, ends there, S2 starts there, and then it ends there. The second member is our rafter, and as you can see there, we have rafters on both sides, and then we have web 1, we have web 2, and then we have web 3. All right, perfect. Now to go over the information here that has been highlighted, we have a span of 8,600, a pitch of 17 degrees, an overhang, which is basically from that point there to there, of 850, and spacing of 1,000. That is the spacing between our trusses. All right, it is 1,000. The following drawing that we will need to have a look at is our truss layout drawing. All right, let us go to that now. Now the second drawing that we will look at is this one, which shows the layout of our trusses, and our trusses basically rest on our wall plate. All right, they rest perpendicular to the wall plate. Our wall plate will go that way. We'll basically say 13,200 minus 270, because this is the gable wall, minus 270, and then we will get the length of our wall plate. All right, now let's move on to the calculations, and yeah. Now you will see here that I've already put down the descriptions for the various items that we are going to be measuring, and I've done so that we can avoid having a long video. And yeah, so the first item that we are going to be measuring is the wall plate, and the description will read 38 by 114 millimeter stone South African pine wall plate. Okay, and this is how we will go about calculating it. We'll take the horizontal length, which is 13,200, and because this is a gable wall, we are going to deduct 270 times 2. That's 270 on either side, and that will give us a total of 12,660. So we'll go down to our dimension column and then write 12.66, and we will multiply that by 2 because we have two wall plates. Okay, that is one on either side. The reason why the wall plate is not measured together with the roof trusses or the structural timbers is because the standard system does say that let's just quickly go there. The standard system does say that members of roof trusses may be grouped together, but wall plates, bearers, etc. shall be given separately. So that is the reason why we are measuring the wall plate separate from the truss members. Okay, now we can go to the truss members. The description for the truss members will read the following in X number full roof trusses with truss members bolted together, bolts also measured, including hoisting up plus minus 2,700 millimeters high from bearing level and fixed in position. Now, the way in which we will work out the number of our trusses, right, is by taking the full horizontal length, which is 13,200, and then we're going to deduct 540, which is the thickness of the wall, 270 millimeter wall thickness, and the third thing we're going to deduct there is the 150 millimeter gap from the edge of our wall plate to the first truss. Okay, so it'll be on both sides, times 2 gap. Right, that will give us a total of 12,360. Okay, now the spacing between our trusses is 1,000, so we would therefore say 12,360 divided by 1,000 centers. That means that it's 1,000 millimeters between our trusses. Okay, 1,000, which gives us 12.36 spaces. And then I'll just briefly show you on Revit how they are positioned. So we will say the number of spaces, 13, so we have 13 spaces, and then we will add a +1 there for our truss, thus giving us a total of, let's see, number of trusses. This will give us a total of 14. Okay, give us a total of 14, and then we go to our description there, we replace that X with 14, and then we put the 14 to show that each and every member that we are going to be measuring will be multiplied by 14. All right, perfect. Okay, so this is basically the 12,360. As you will see here, we said 13,200 minus 270 minus 270, and then minus 150. That's the distance from there to there. It's 150. Same story this side. Now I just want us to calculate the number of spaces between our trusses. All right, so we have 1, 2, 3, 4, and these are 1,000 apart. Ne? 1, 2, 3, 4, 5, 6, and I'm going to skip that one there, 7, 8, 9, 10, 11, 12. These are 12 full spaces. Ne? And then the 0.36, which is 360 millimeters, is basically this space here. Right, now this is not how they would put the trusses down, but an adjustment would be made to the centers, all right, or to the spacings. Now, what if I include that space to the number of 12 spaces that I have? It goes to 13, right? So we basically, essentially, we then have 13 spaces. Now I want us to calculate the number of the trusses. All right, so it would be 1, that's the first one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is basically the number of our trusses and the number of our spaces. Now that we have determined the number of trusses, we can move on to measuring the members of our trusses. I would just like for us to have a look at the truss detail, and that is where we are going to get all of our information from. So the next part of our exercise involves scaling off the measurements from this drawing over here. Now the first member that we are going to scale is our tie beam. Now this over here is our tie beam. Okay. Now just to go over this information again, I just want us to have a look at the span. So we are told that the span is 8,600. That is from one side of our wall to the other side, we have a span of 8,600. Therefore, meaning that our tie beam will be 8,600 millimeter long. Perfect. Now, if you look closely here, we have a connection there. All right. Now, the reason why we have a connection there is because two structural timbers, which are S1 and S2, were joined together to form this long 8,600 millimeter tie beam. Okay. Now, if you have your scale ruler, we will be using a scale of 1:60. And if you don't have a scale ruler of 1:60 like myself, you can use your 30 centimeter ruler to determine the measurements. All right. So we'll start first with the tie beam. Okay. Now, if I put my ruler here, I get 18 centimeters. And we know that 18 centimeters when multiplied by 10 gives us 180 millimeters. Now I need to convert that to the correct scale. 1 unit on your scale ruler represents 60 millimeters of the actual object. Okay, so we'd have 1/60, which is equal to, what did we scale? We scaled 180 millimeters. All right, and then that there we have it as unknown. So when you cross multiply, that gives you 10,800. All right, but now there is a difference there between the actual, which is 8,600, and what we just measured off the drawing. Now the reason for that is that the printer may rescale an image to fit the different sized paper. All right, which results in an inaccurate printout. Okay, the inaccuracies are due to any form of copying or processing of a drawing. However, that is not a train smash. Okay, if the drawing hasn't been printed to the required scale, the first thing we need to do is find an object of known length, which in our case obviously is the 8,600. All right, so we would say, and this is basically the scale factor or true factor. Okay, so we would say 8,600, that is the object of known length divided by the measurement that we just scaled, and that gives us 8,600. That gives us 0.80. Okay, we can just quickly check there as well, just to make sure that we're doing the correct thing. So I have there 30 millimeters, so we would go 1/60 equals 30 over x. X gives us 1,800. All right, so we would take the known length, which is 1431, and then we would divide it by 1,800. That gives us 0.79, and they're not too far apart, right? It's just short by 0.01. Okay, perfect. So I will use the 0.80. Now it just basically means that each and every member that we scale off from the drawing, after multiplying it by the required scale, because I don't have a scale ruler. If you have a scale ruler, all you would need to do is just scale and then multiply with the true factor. Now if you're using a normal 30 centimeter ruler, you would scale off from the drawing, multiply by the required scale, and then multiply by the scale factor to make those adjustments. All right, great. Now we can get started. The first item there that I will measure is the tie beam. Okay, and that there, what I'm getting there is, what I'm getting there is 107 millimeters. But obviously it will be the remainder of 10,800. Okay, so we'll just simply say 107 multiplied by 60, which gives us 6,420 millimeters. So this there is 6,420 millimeters. This is before you multiply it with the scale factor. Okay, so we'll say 10,800 minus 6,420. It will give us 4,380 millimeters. Now these haven't been multiplied with the scale factor yet, all right? Yeah, let us just put that down and then move on to the other members. Okay, now we already determined the true factor or scale factor. I just want us to put it down on Excel sheet, and we got to an answer. We arrived to an answer of 0.80. Now moving on to the truss members. Okay, we said we have S1, S2, and that's for the tie beam. And the scale dimension we got there for S1 was 107 millimeters, right? And then we converted that 107 millimeters to the required scale of 1:60, and we got to a value of 6,420. So we would say 6,420 multiplied by 0.80, which is that scale factor over there, and it gives us 5,136. And the second one, we said 10,800, which is the total scale length, and then we subtracted the 6,420 from it, and we got an answer of 4,380. So we would say 4,380 multiplied by 0.80, and that gives us 3,504. Now before we move on to the other members, there's something that I want to discuss briefly. The standard system on page 56, clause 4, right, under structural timbers, reads, structural timbers other than laminated timbers required to be in single length shall be given in the following categories: lengths not exceeding 2.4 meters, exceeding 2.4 not exceeding 3.9, exceeding 3.9 not exceeding 6.6, exceeding 6.6 meters. Now for the first one, which is S1, it's 5136, so it means that it will fall under the category exceeding 3.9 not exceeding 6.6. And the second one, it's 3504, it will exceed 2.4 but not exceed 3.9. Now let us just go on to the other members as well. Now I just want us to go back to our drawing and determine the lengths for various truss members, and then we'll finish off with putting the dimensions down. Okay, so now the following member that we are going to measure is our rafter. Okay, I'm going to take it from that point there up to there, and I am basically getting 114. So for rafters, I'm getting 114. It means that we would say 114 multiplied by 60, which is the scale, and then multiplied by 0.80, and that gives us 5,472 categories. Let's just put that there down there. All right, and then we'll move on to web 1. Then I'm going to take the measurements from that point here. I just extended the leg, so I'll take it from there to this point there, and this might not be accurate because I'm not using like a scale ruler. So yeah, if you get a different answer, it's fine. It should just be in the same region as mine, even if it's not exactly the same. All right, so I am getting there 44. I'm getting 44. Web 1. is equal to 44 multiplied by 60 multiplied by 0.80, which gives us 2112. And then the second one will be web 2. Okay, same story there. Take it from there to down here, and I'm getting 22. I'm getting 22. Web 2 is equal to 22 multiplied by 60 multiplied by 0.80, which gives us 1056. And then we'll move on to web 3. We have we have 42. We have 42. So we would say 42 multiplied by 60 multiplied by 0.80, which gives us 2060. All right. Now the categories that they will fall under, strat 1, it will fall under exceeding 3.9 meters, not exceeding 6.6 meters. This one will fall under exceeding 2.4 meters, not exceeding 3.9 meters. And then our after will be the same as strat 1, which will be exceeding 3.9 meters, not exceeding 6.6 meters. And then web 1 will fall under not exceeding 2.4, as well as web 2 and web 3, not exceeding 2.4 meters. All right, now let's just put the lengths down there. For strat 1 we have 5.14, so we have 5.14, and we are going to multiply it by 14 because that's the number of the trusses that we got to. Okay, multiplied by 14, and then we go to the rafter. Our rafter is 5.472, which is 5.47. We'll multiply it by 14, and we'll also multiply it by 2 because we have 2 on one truss. And then we're done with timbers that fall under that category. Now the second category, I'll take it off if you would like to, so that you don't write them all over again. So the second category that we have there, I said it's exceeding, let's just do this. I said it's exceeding 2.4 meters, not exceeding 3.9. Okay, so we would have ditto, we would say ditto, referring to the 38 by 114 millimeter SSAP, ditto, but exceeding 2.4 meters, not exceeding 3.9 meters long. Okay, and that would be 3.50. That's for strut 2. Let's just put that down there, strut 2, and then we'll multiply that by 14. Perfect. Now the last category, there is not exceeding 2.4 meters long. The first one we have there is 2.11, and this is web 1. We have web 2, and then we also have web 3. For web 2 we have 1.06, and then web 3 we have 2.02. Okay, Now web 1 we multiplied by 14 trusses, the number of trusses 14, and then there's 2 on every truss, so we multiply that by 2. Web 2, same story, 14 trusses multiplied by 2 because there's 2 on each truss. And then web 3, same thing as well, 14 multiplied by 2 because there's 2 on every truss. Now this is basically the end of our exercise, and yeah, I really hope that you enjoyed and that you learned a little something, and yeah, all the best.